Hello, ladies and gentlemen, and welcome to our fission practice problem. So we're going to talk about how to do a fission reaction using alpha decay. So the first thing you're going to do is we are going to start. I'm going to play this video as we go. What we want to do is we want to create our equation by writing out the mass of our reaction. So this one here, or sorry, mass of our element. So 226 comes from radium 226. So I went to my periodic table. I also used that chart of elements that I told you guys about. And I looked up and radium 226 is on my isotope chart. And so I use that and its atomic number. So I write in the atomic number. I'm also going to write in its element symbol. Now, because we're doing alpha decay, alpha is meaning helium. So what I'm going to do is I'm going to write 4 and 2 because 4 is the mass of helium, 2 is the amount of its atomic number. So what you want to do when you're doing this is you want to move from radium to the new element that we are going to create. So how we do that is we use this mass of 226 and we subtract the mass of helium. So in the end, I get 222 as my new mass. I take my atomic number, I subtract the 2 from it, and I am going to end up with 86 as my new number. So I'm going to put my atomic mass of 222, my atomic number of 86. I'm going to go to my chart and I'm going to find that it is radon. So that is how we create an create an alpha decay equation. Okay, so if I'll just show you the end of that again. Okay, so again, here it is. Oh, sorry guys, let's try that again. Okay, so here's my alpha decay showing you how I got to my new element of radon. All right, so let's look at the next one. This one says, write a nuclear reaction, alpha decay of polonium-210. And I'm going to go to that chart first, my ionizing chart. I'm going to look for polonium-210, and I'm going to write down its atomic number and its mass. Now it's asking me to do alpha decay, so that means we have to use helium. So here we go, question number 2. So here in number 2, I'm going to start off again by creating my known, which is my polonium, and I'm doing alpha decay. So I'm going to start my equation with 210 as the mass, and I have 84 for polonium. I just looked it up on the chart. Now again, helium is for alpha decay, so I'm going to take my 210 and I'm going to subtract 4 from it to get 206. Then I'm going to take my 84, I'm going to subtract 2 from it, and I'm going to get 82. So my new element has a mass of 206, an atomic number of 82, and if I look on the periodic table, 82 is now going to be lead. So let's do the next practice problem. Okay, so this one is talking about the nuclear reaction of beta decay. Now, beta decay is different because beta decay is about losing electrons. So you actually create gamma radiation off of this. Okay, we lose, and we're going to create a gamma particle. But for our purposes, we don't need to represent the gamma particle, which I showed you in your book is 0, 0. Okay, we're just going to show beta decay. So number 3 says the beta decay of cesium-144. So your first inclination is to go to your chart and look at the chart of all the ionizing different elements. So you're going to see if cesium-144 is there. So I look at it, I look to see if it is. If it is, then perfect. I go 144 over 52. Now 55, sorry. Cesium is on that chart. If you couldn't find it on that chart, you would go and look for cesium as the element. You would keep the number here, but then use 55 because that's atomic number. Now for beta decay, this time what we do is we are going to actually take away an electron. So you can see here 144 minus 0 is still 144. But now what we're doing is we're taking 55 and we are subtracting a -1. Whenever you subtract a negative, okay, they cancel each other out and they become a positive. So instead of taking 1 away and becoming 54, this actually becomes 56. Okay, so 55 becomes 56 because when we remove a negative number, so subtracting a negative, it turns that negative into a positive, and we're going to add it in. So now my new number is 144 over 56. So I go to the periodic table, look for 56, and I find that it's barium. Practice problem number 4 is about the alpha decay of Americium 241. So just like the other practice problems, I'm just showing you what we're doing. So alpha decay uses helium, so the 4 and the 2. So Americium, okay, we are going to write it down as 241 as the mass. And again, check your chart. If it's there, use what it is, 241, and then its atomic number of 95. We're doing alpha decay, so we are using helium, and we are going to lose 4 from this number to get you 237. And we're going to lose 2 off of the atomic number to give you 93. Now again, go to your periodic table, look for 93. There's your mass, 93. So you end up getting Neptunium as your answer. Let's do number 5. Now we're going to look at the decay of thorium-232. Again, ladies and gentlemen, you want to set up your equation. You don't have to write down what I'm writing down every single time. You just need to write down the equation part of it. So again, 232 is its mass. And it's going to be over its atomic number. And that is thorium. We are using alpha decay. So we're 4, 2 with helium. So we want to figure out what our new element is by taking 232 and subtracting 4, which gives us 228. We want to take 90 and subtract it, and we get 88. 88 is our atomic number, so we're going to use it to find it on the periodic table. And when we do, we find radium. Our very last problem is going to be beta decay of radon-222. So again, beta decay is using an electron. And when you lose an electron, because you're subtracting an electron, it becomes a positive. So remember, your number on the bottom gains a bigger number. So we're going to do radon-222. So 222 is the mass. And radon has an atomic number of 86, and there's its element symbol. So we're going to show the 0 and -1 with the electron symbol. We're going to take 222, subtract 0, which leaves us with 222. So we're going to have the same mass, but this time 86 minus a -1 is going to end up with an 87. So even though our masses are the same, this makes it an isotope. 87 on the periodic table is francium. So that is how you do these practice problems. If you have any questions, please let me know.